In this video, we're going to start looking at a application of differentiation, and namely that's optimization. So to kind of motivate this discussion, we're just going to do sort of a quick numerical experiment, and that'll motivate what we're trying to do here. So I'm going to make sort of a table to do some numerical examples, and we'll just kind of go from there. All right, so here's basically the problem that we're going to work on. So problem. We've got two numbers, and they add up to 210. Now there's lots of different numbers that could do that, of course, and we want to maximize the product. Okay, so for example, we could do 210 and 0 as two numbers, but that would be a really bad idea because then the product is 0. But if we did something like, say, 100 and 110, then the product is definitely way bigger than 0. So there's lots of different configurations we could split this 210 into, and we just want to figure out, well, which one is going to give us the biggest product. Okay, so to kind of attack this, let's just make sort of a table here. And I'm going to have actually 3 columns. And what those are going to be is in the first entry, I'm going to put the first number. And then I'm going to put the second number here. And I'm going to put the product there. Okay, so I'm just going to kind of choose a bunch of these just sort of as an experiment. We'll do 60, and then 70, and then 80, and then 90, and then 100, and lastly we'll do 110. Okay, so these are all the values that I'm going to use for the first number. And then the second number, well, since they have to add up to 210, the second number is always going to be 210 minus the first one. And I'm going to write it in this form just to kind of remind us what we're doing here. And then in the product column, we just need to actually compute what's this thing times that thing. Okay, so I've done all these computations in advance just for the sake of time, and so what I ended up getting was for this one, we got 9,000, that's 60 times 210 minus 60, and then I'll just keep writing in the rest of them here. For the next one, we got 9,800. And then for the next one, I got 10,400. So 10,400. And then the next one, we got 10,800. So this is good. We're going up. And then the next one, I got 11,000. And for the last one, I also got 11,000. Oops, 11,000. Okay, so I've just taken a bunch of different pairs of numbers that add up to 210 and just computed the products. And what we found here is that the numbers, as we're getting sort of around 100-ish, the product seems to be getting a little bit bigger. And let's actually do one more here just for to see kind of what's going on. If I do 120, here I get, again, 10,800. So this would be 210 minus 120. Okay, so looking at this, we can kind of guess what we think the maximum product is going to be and where it occurs. And so let me just kind of highlight some stuff here. This stuff in the middle seems to be pretty promising. So for numbers smaller than 100 for number 1, we got a product that was less than 10,000. And when the numbers are bigger than 110, we also start getting products that are smaller than 11,000. So maybe somewhere in between is where the magic is happening. Okay, so at this point we might make just sort of a guess. What about if we let the first number be 105? Just split the difference. And then the second number would be 210 minus 105, and that in this case happens to also be 105. So let's just see what is 105 times 105. And if we beat this 11,000, then maybe that's a good idea. Okay, so let's just compute here real quick. What is 105 times 105? And I'll just put this in the calculator real quick. And the calculator says that I get 11,025. So I have beaten the previous record by not much, but enough that it's actually bigger. So 11,025 is bigger than 11,000, and that occurred when I had 105 for both numbers. Now, this does not prove that 11,025 is the biggest, although it's certainly the biggest of the numbers that we've plugged into yet. Now, you might guess that this is what it is, but we really need to demonstrate that that's in fact correct. So that's what we'll look at here next. So the way that we're going to do this analytically, and this number crunching stuff is great for motivation, but it's not practical. So let's do this the real way. The function that we're dealing with here, I'll call p of x for product. And as we've seen, this function is a number x times another number 210 minus x. And it's 210 minus x because the numbers have to add up to 210. So these two numbers, x and 210 minus x, add up to 210, and their product is what we're interested in optimizing. Okay, now I'm going to go ahead and multiply this out, and I get 210x minus x squared. We're trying to find the maximum of this function. And we already know how to do that once you actually have a function like this. What we need to do is take the derivative. And let me clean this up here. So if we take the derivative of this function, we get 210 minus 2x. And as we've seen before, we're interested in places, well, optimization happens, maxes and mins, whenever the derivative is 0. So I'm going to take my derivative, set it equal to 0, and solve. And in this case, we get 2x is 210, x is 105. Okay, now that's really good because that's exactly what we kind of had guessed before. And then the other number would be also 105, just 210 minus 105. Okay, so our guess from before that the two numbers needed to be 105 looks even more promising. Now, we've noticed that something happens to this function at 105, namely we achieve an extreme value. But what we don't know yet is whether or not that extreme value is the max versus the min. We probably are guessing it's the max just from the numbers, but we need to demonstrate that that's in fact true. Okay, so let's use the second derivative test here. And my second derivative is just minus 2. This is negative. So p double prime of 105 is less than 0, and that implies that 105 comma f of 105 is a local max. And that's good because that's what we were trying to do, was to find the maximum here. Okay, so what have we found? We found that the max occurs, to our problem, maximum occurs when both numbers are 105. So max occurs when both numbers are 105, and the maximum product is 105 times 105, and we got 11,025. Okay, so in class what we're going to look at are more exotic examples of this, where all we do is this analytic stuff, and this sort of experimental number crunching will go out the window. It kind of motivates what we're doing here, but of course the real idea is to do this with calculus. Okay, so I'll see you in class.